another way that we can solve quadratic equations, and that is by completing the square. This is used a lot in pre-calculus, so you'll probably want to save these notes for whenever you take pre-calc. I think it's in your summer packet, and I know Mr. Foley expects you to know how to do it. So, so far we've learned 3 ways to solve quadratics. What is one way we have learned to solve quadratics? Caleb? What's that? Graphing? I'll just put graphing with our calculator, right? What's another way we learn, Eric? That would be solving systems of equations, not quadratics. You're thinking, like if we had 2 systems of equations, but I'm looking at a so an x squared function. So we learned graphing on the graphing calculator. What else have we learned? Square rooting. And what's the other way we learn to solve things? Ashley? Factoring. Yes. Unfoiling, basically, the reverse, the converse of factoring. Okay, today we're going to learn a 4th method, and that is completing the square. Now, completing the square is kind of a longer process, at least at first, until you get the hang of it. It's usually only used when you can't factor, when you can't square root, and also when you can't graph. But sometimes it can be used in place of the graphing calculator too, if it was in the calculator problem. Okay. Now, to complete the square, what we're going to do is we're going to be completing the equation to make a perfect square trinomial. Okay, so an example of a perfect square trinomial would be like this. It's called a perfect square trinomial because when you factor it, you get the exact same binomials. So this would factor into x plus 5 and x plus 5, which would be x plus 5 quantity squared. That's a perfect square trinomial. So what we're going to do today is we're going to make the equations look like this so that we can factor them and be exactly the same, and then we'll be able to square root the binomial square. Okay. So you can solve equations in which one side is a perfect square trinomial. By finding square roots. And we are not going to do example B in this section because normally if this were the equation given to you, since we have a perfect square trinomial, a lot of times would just subtract 36 and factor it like we normally do. But I'm going to show you how to do it when it is a perfect square trinomial, then we'll do it when it's not. So we would factor this left side just like I showed you up here. So this would factor down into be x plus 5, or x plus 5 quantity squared. And then we can square root both sides. Now when you square root a square, these undo one another. We're left with x plus 5. What would I be left with over here? Garrett?
6.
Is it close? Plus or minus 6. So now you basically have to set up 2 equations. One where x plus 5 equals 6, and one where x plus 5 equals negative 6. That way we get our 2 answers. So we subtract 5 from both sides. We'll get x equals 1. And we'll subtract 5 on both sides. And we'll get x equals negative 11. Now, if this were the problem given to me personally, and it just said solve, I would have probably subtracted 36, and then I would have solved by factoring. What we're going to look at below is when we have equations that are not factorable. And that's when completing the square is really useful, when they're not factorable and they're not square rootable to begin with. All right, so if one side of an equation is not a perfect square trinomial, you can actually rewrite it to force it into being one. So you can rewrite the equation to make a perfect square trinomial. The process of finding the last term of the perfect square trinomial is called completing the square. Because you're completing the equation to make it into a perfect square trinomial. So just kind of looking at where we're going, we're going to be asked to solve this. Is this factorable? Do we know numbers that multiply to 1 and that add to 4? No. Okay, so the equations that we're going to see today are going to not be factorable. They're also not square rootable, right? The only way you could solve this then would be with your graphing calculator, which I'm going to tell you on this problem you're not allowed to use it. Or you'll have to complete the square. Okay? So to complete the square, you are going to get the quadratic in this form. Ax squared plus bx equals c. So instead of having it set equal to 0, you're actually going to get the constant on the other side. And then what you're going to do is you're going to actually add a number to both sides of the equation. Remember, you can add and subtract to both sides as long as it's the same number, like when we solve an equation. So you're going to add a number to both sides to force this to be a perfect square trinomial. Now, to figure out what the number is, you're going to use this formula, which you want to memorize. So you're going to find out what b divided by 2 is and square it, and that's going to get added to both sides. Once you do that, you're then going to have a perfect square trinomial, something that will factor to be itself squared, and then you'll be able to solve it without your graphing calculator. All right, example 2 just asks us to find the missing value to complete the square. So all it wants you to do is use the formula b divided by 2 squared, and make sure you know how to plug in the values. So we know that this is our a value, this would be 1. Our b value will be 20. So to figure out what completes the square, I would do b, which is 20, divided by 2, and then I would square it. You do want to use parentheses first to get 10, then square it to get 100. Now check and make sure this is a perfect square trinomial. If I were to factor this, I would factor into x plus 10, x plus 10, which is exactly the same, which means it's a perfect square trinomial. Okay, now the next one, a is 1, b is 7, so I'm going to do b divided by 2 squared. Okay, now you don't probably want to make this 3.5, even though 7/2 is 3.5. If you have to square 3.5, most of you don't know what that is, so you'd have to do long multiplication up to the side with a no calculator. So leave this as a fraction and square the top and square the bottom. So this would be 7 squared over 2 squared, which is 49 over 4. You'll want to leave them as fractions, even though I know most of you don't like fractions. You will in this unit, because when you go to factor this, it's actually going to be whatever it was before you squared it that goes back in your equation. So this would be x plus 7/2 squared. So we kind of want to show the work for it, even if you're a mental math person. All right, now let's actually solve this equation, because it's not factorable, it's not square rootable. We're going to solve it by completing the square. So step 1 says to get the equation in this format. So I need to move the constant over. So I would subtract 1 from both sides. Now, when I do this, I add in this little blank line, this little space. to remind myself, I'm going to add something to both sides. So I would write x squared plus 4x plus blank equals negative 1 plus blank. Just to remind myself, I'm going to add something to both sides. To figure out what that something is, I'm going to use my b divided by 2 squared formula. So b is 4. So this would be 4 divided by 2 squared, which will get me 2 squared, which will get me 4. So I'm going to add 4 to both sides of the equation. On the left-hand side now, this should be a perfect square trinomial. What does this factor down into? Abby? X plus 2, x plus 2, right? If you did it correctly, it'll factor into something that is exactly the same. So you want to rewrite that as x plus 2 quantity squared. On the other side, you actually are going to add these numbers together. So negative 1 plus 4 gets me 3. Now, we're going to find the square root. So we're going to take the square root of both sides. And I'm going to say take the positive and negative square root of both sides. You have to put in your plus or minus. So we'll square root and we'll square root. Again, squaring and square rooting cancel each other out. So I'm left with x plus 2 equals, at this point, I don't know the square root of 3. So I'm going to leave it plus or minus the square root of 3. Now at the end, you need to know what x actually is. Right now we have what x plus 2 is. So the very last step is to actually use inverse operations to solve for x. So we would subtract 2 on both sides. Now, technically you can subtract 2 at the end, but on the answer key and how most mathematicians write it is they'll put it in front of the plus or minus sign. So this negative 2 would actually go here. And then your final answer, I'll come over here, would be negative 2 plus or minus the square root of 3. If you want to split it up into 2 answers, you could. That would be negative 2 plus the square root of 3 and negative 2 minus the square root of 3. But your answer is going to stay like that. You could type it in your calculator and get a decimal, but we're going to be doing this without a calculator. So the next one, I kind of want to move this up so let me place this stuff to get myself some room.
Yes. Like, how are we able to write just one? Will we be able to do that in all of them?
Yes. Yes. For most of these, you're going to end up being able to write it like this. Now, let's suppose that we got this as an answer, 2 plus or minus 3. Where we don't have any square roots, you would actually want to find the 2 answers. So you would actually want to do 2 plus 3 and 2 minus 3 to get 5 and negative 1 as your answers. But if one part is a rational number, one part's an irrational, you can't combine them, so you're able to leave it like that. Good question. All right, this next one, we can see that we are already in the format that we want. The C value has been moved over. So I'm just going to add in my plus blank on both sides. I'm going to complete the square. I'm going to make it a perfect square trinomial, adding something to both sides. So to figure out what this is, I'm going to do b divided by 2 squared. Four divided by 2 squared is 2, which will get me 4. So this, I'm adding the same number to both sides. I am going to get a different answer though, promise. So the left-hand side will factor down into x plus 2, or x plus 2 quantity squared. On the right-hand side, I'll get 8. Then we square root. And if you want, you could put your plus or minus in right then, so you don't forget. But you have to have it on the next line. So I'm going to get x plus 2 equals plus or minus the square root of 8. Now a lot of you will just subtract 2 on both sides at this point, which is fine. Negative 2 plus or minus the square root of 8. And you'll circle that, and you will get marked either a half point, probably a half point off. Why is this not my final answer? Abby?
You can break down the square root of 1.
Good. You can break down and simplify the square root of 8. So this will become the square root of 4 and the square root of 2. The square root of 4 is 2. So my final answer here should be negative 2 plus or minus 2 square roots of 2. You cannot combine the negative 2 and the positive 2 because this is multiplication and this is addition. So those have to stay together. Okay, let's see. Why don't you guys try 4a on your own? I definitely want to do b with you because it gets you fractions and it's a little bit harder. Why don't you try example 2a on your own? I rewrote the steps back here. So for this one, obviously the first thing to do is to move the 7 over because this is not factorable. Eventually you'll get to problems and it'll say solve. You want to try to factor if you can because that's much faster, but this is not factorable. So we'll subtract 7 on both sides. And we'll add in our little spaces for what we're going to add to both sides to complete the square. What is b in this problem, Abby? Good. b is 1. So when we do b divided by 2 squared, you do want to show work for this, especially for the fraction ones, even though I know you can do it in your head. So this would be 1 divided by 2 squared. Yes, you can make that 0.5, but it's much more difficult to factor it using decimals than it is with fractions, actually. So now you're going to square the top and square the bottom. Right here, a big mistake I see is you forget to square the denominator. You're squaring the 1 and the 2. We'll get 1/4. So I'm going to add 1/4 to both sides. Now, students will say to me, Mrs. Bennett, how the heck do I factor when there's a fraction? How do I know what's going to go in? To know what it factors into, you just have to look up to what it was before you squared it. That's what it will factor into. If you look over here at what Abby had before, Ashley. What Ashley had before she squared it, she had a positive 3, and that's what it ended up being. So you don't really have to think about what it factors into, you just have to look at your work. So this should factor into x plus 1/2 quantity squared. If you don't believe me, you could check it by foiling. You'll end up getting 1/2 x plus 1/2 x, which will get you 1x, and 1/2 times 1/2, which will get you 1/4. Now over on this side, this is what makes the problem harder. What do I need to do in order to add these two together? Yes, you most likely need a common denominator. You could do a mixed number, but later on you're going to have to subtract a half. So it's probably easiest to get a common denominator. So the common denominator would be 4. So we would then multiply this by 4 and this by 4 to get, and I'll do it off to the side, negative 28/4 plus 1/4. Then we add the numerators. Negative 28 plus 1 would be negative 27. You do not add the denominators, it would stay the same. Negative 27/4. What would I do next? Abby? Square root both sides. Remember to put your plus or minus if I'm not numerical side. So our square and our square root cancel out. I'm left with x plus 1/2 equals. Now with the square root, a couple things. We want to leave our plus or minus. You probably want to bring the negative out and make it I. And you'll want to split the square root to be the square root of the top and the square root of the bottom. 27 under a square root and 4. Now before you start rationalizing, the denominator is a perfect square. So just take the square root of 4 to be 2. Now the 27, can I simplify this? Yes, we can break this down into the square root of 9 times the square root of 3. The square root of 9 is 3. So at this point I would have x plus 1/2 equals plus or minus. Now we have an outside of 3 and an I, so usually I'll write that as 3i instead of I3. 3i square roots of 3 over 2. Last step is then inverse operations. I need to undo positive 1/2 with a subtraction of 1/2. Again, usually we write that in front of the plus or minus symbol. So this would be negative 1/2 plus or minus 3i square roots of 3 over 2, which is how I'm fine with you leaving it. The book answers, which are what are posted on my classroom, sometimes they'll rewrite this as one big fraction. So they could write it as negative 1 plus or minus 3i square roots of 3 all over 2. That's the same thing, splitting it up. So I don't care which way you write it, but just make sure you realize those are the same things. I'm going to pass out the homework. I do want you to do at least one problem on the homework.